Hello everyone. So in today's session, we are going to learn about acceleration sensor. So this is your three-axis accelerometer sensor. So what it is used for or why we need this? So as we have seen that in our various mobile application, you can see that we need to sense the tilting motion. For example, we are playing some game. We need to sense the tilting angle or tilting motion. Then we need some kind of sensor which can sense that like the gravity, acceleration of your gravities a sudden jerk or a just sudden shock. So this kind of sensor can sense that easily. So let me zoom it to. So this is your accelerometer sensor. Now, if you see it carefully, here it is written ADXL 345. So 345 is its version. ADXL stands for your accelerometer sensor. Now here you can see it. It also has this symbol. There is X, Y, Z. So this is your three axis. Like it can sense in your X, Y, and Z. Let me also share you a picture. Okay, so on my left hand side, you can see we have a picture that how the three axes will work. Like for example, the up and down is for your Z axis, the left and right is for your X, then we have the up and down for Y. Apart from them, we have three other options that is your pitch, roll, and yawn. So if I rotate my accelerometer like this, means it is your one. If I'm rolling like this, it is your roll. If in pitch, like it is in this motion, I can roll it like this also. So it is your roll. If I'm rolling like this, it is your pitch. And if I'm moving it like this, it is your yaw. So these are the three factors when we use a three-axis accelerometer. Now let's learn about the pins diagram we have in here. So let me show. Okay, here you can see that. Okay. We have ground and VCC for powering it up. Then we have CS for chip select. Then we have INT, that is interrupt 1 and 2. Then SD not, SDA and SCL. So here you can see this is our I2C connection, SDA and SCL. Then we have interrupt also and chip select. So it is our SPI connections also. So it is both SPI as well as our I2C connections we have in our um, three-axis accelerometer. Now let's see how we can connect it with our Arduino. So let me show you again a picture. Okay. So on my left hand side, when you can see we have another picture in which you can see how the connection will be made. So here you can see we will use only four pins here. So the first two pins are for your powering it up, that is your VCC and ground. So let me plug it in your breadboard. So here you can see I plugged it in different ports so that we can easily identify. So from here, if you see the first and second pin is your ground and VCC. So we are going to use those two pins. So I am using two jumper wires, male to male, and connect the ground with your ground pin with my Arduino and your VCC with a 5 volt. Okay. So this is the two connection for powering it up. After that, we have to use two more pins. That is your SD and SCL. So it is your I2C connection. So let me use again two jumper wires. Okay. Now let's see how the connection will work. So our SCL will connect to our A5. So this last pin is your SCL. It will connect to your A5. And then we have A4. So that's it. We have the connection. Now let's understand the code. So for coding it, we have a library of the same name. That is the name which we have here. If you see it carefully. Yeah. ADXL 345. So we have to search it on Google. So let me show you how you have to do it. Okay. So open a browser, any browser that you are using, and search for your the number which I have shown you just here. That is your ADXL. Now search for library. Now here you can see that we have various options in library. What you have to do, you have to just go to the official website of our Arduino and just download that library. So as I already downloaded it, so let me show you what you have to do after downloading the library. Just open a new sketch file, go to file section. From file, go to example, and if you see on your example list, you will see that we have a sensor here, accelerometer ADXL 345, and we have a demo code. Just open that code. Okay, here you can see this is your demo code. Now what you have to do, just upload this code. This will fetch your XY and Z values. So before uploading the code, let me connect the uploading cable. So, okay. So my component, let me upload it. We have one ground here also, you can use it. Okay. So after 13 number pin, we also have a ground, so we can use it too. So this is my connection, the basic connection which we have. Now, let's say write some code for it. Okay, there is one more thing that you should know. That let me turn on the serial monitor. Okay, so let's say I use only two colors, so it will be much easier for us to understand. That is our red and green. Okay, so when I am moving like this first side, our red will be turned on, and when I do this, it will be turned off, and vice versa for here, green, and we will be closing it. So let me hide this comfort for now. Let's go to our code. So here, what I have to do, let's say I don't want to print these things. So let me comment it for now. Or what I can do, I can copy it and create a new file and paste it in that, so that our actual code file don't be harmed. Let me share it with you also. Okay. Now, if we get a value, let's say for when we are moving like this, the x value is like changing. So by default, the x value which we have is like we have 4, and when I move it like this, it is the x value is changing here also, here only. It is around 200. So if x is greater than or equals to, let's say 200, then what should we have to do? Digital, digital right. We will turn on, let's say, this green one. So green is being connected with pin number 7, 7 comma 5. Okay. And if, let's say, I copy it, and if x value is less than or equals to, let's say, -4, then it should be low. This is for the only a single one. What we want to do? We want to do the same for your other this red color LEDs also, and this will be changed according to your let's say here when we change it like this, so it will be your y value. So here it is more negative, and when I put it here, it is positive. Okay. So let's say uh, if y value, let's say we do only for positive and negative, is less than 0, then turn what we have put, we will turn 6 number LED will be low, and as if it is greater than 0, then 6 will be high. Okay. Let's upload this code. Okay, so the code has been uploaded. Let's check it. Okay. So if I touch it like this, the LED should red LED should turn on. You can see it has been turned on. Here it is not, because it is more negative, but here it is positive. Now for Y, like for the green one, here it is like we got the value 200, and here it is no. Now let me also show the compound values also. So I think here you can see the compound value. So we have the X value as your 5. Now let me increase it. It is increasing. We have set it for 200. Okay, 200 has reached. You can see that LED has been turned on. When should it turn off? After 0. So it has turned off now. For the Y, here you can see below, like it should be greater than 0 to turn it on. The second value, it is 46, 47 around, so it is greater than 0, turn on. If it is less than 0, it has been turned off. So like we can create a gesture control, like if I put it in my hand like this and it's like if I move it here, it's turning on. If I move it like this, turning on. So I can create a gesture control robot, or I can interface it with motors also. So these are the tasks which we can do it with our accelerometer sensor. So that's it for today. We'll be in the next session.